Breaking news. We have yet another extraordinary development unfolding inside our solar system this morning. And if you thought the arrival of XG427 last week was already pushing the boundaries of coincidence, what you're about to hear stretches that boundary into something far more unsettling. A newly confirmed object, temporarily designated QN581 by the Minor Planet Center, has just been detected accelerating inward from a direction that does not correspond to any known comet family, asteroid group, or debris stream. But the strangeness doesn't end there. Its trajectory is slipping into the exact same observational corridor that already hosts three I/ATLAS C/2025, V1 Borisov, K1 ATLAS, and XG4275. Anomalous bodies, all behaving in ways that defy the usual assumptions about natural visitors to our solar system, are now converging in one narrow slice of sky, and the geometry between them is becoming almost impossible to ignore. Before we go deeper, I want to make something extremely clear. We are not talking about alien probes. We are not talking about intelligent craft. These are not the conclusions, but the patterns, the alignments, the physical behavior, the resistance to solar radiation, the synchronized arrival windows are no longer falling into the category of ordinary by any stretch of imagination, and QN581 is arriving like a final puzzle piece sliding quietly into place. Let's break this down from the beginning. Earlier today, at 3:14 a.m. UTC, a team of Chilean observers running a custom wide-field survey telescope flagged what they believed was a calibration error. They noticed a dim, faintly hazy point with an inconsistent brightening pattern drifting across multiple exposures. At first glance, it resembled cosmic ray interference or a satellite flare, but when they separated the stacked images and checked each frame individually, the odd brightening held. Something was moving, something compact, something with a barely visible coma, but absolutely no detectable tail. It matched the exact same early signatures we saw with XG427 and 3, I/ATLAS. Unstable magnitude curves, faint haze, the absence of outgassing structures, and the presence of non-gravitational acceleration far too early in the observational window. The detection was submitted. Within 90 minutes, a second confirmation came from a northern observatory in the Canary Islands. QN581 was real, and its inbound trajectory was unlike anything in the current Comet catalog. It's approaching along a shallow inclination that runs almost parallel to the ecliptic plane, dropping into the sky from an angle that seems designed, yes, designed, to align itself with the same Virgo-Leo corridor that already holds the other anomalies. When we load its provisional orbital elements into our 3D simulation, the geometric alignment becomes obvious. But before we visualize it, let's establish the context. Right now, as of this morning, Earth is positioned at an angle that gives us a perfect pre-dawn viewing window into a corridor spanning only two constellations, Virgo and Leo. Inside that corridor sit three I/ATLAS, V1 Borisov, K1 ATLAS, and XG427, each one an outlier by every conventional definition of cometary behavior. And now QN581 is descending into that same patch of sky, like a final bead sliding onto a cosmic string. If you're getting the sense that this moment feels scripted, orchestrated, or part of a larger sequence, trust me, you're not alone. Let's load up our 3D simulation. We begin with Earth at the center of our observational frame. Then we overlay three I/ATLAS, the interstellar visitor with the hyperbolic velocity that first sparked global attention. Next we add C/2025 V1 Borisov, a rogue object that appeared between Earth and Atlas in a configuration so improbable it ignited weeks of speculation. Then we add C/2025 K1 Atlas, the golden-tailed comet sitting unusually low in the Earth-Sun system. After that comes XG427, the compact, tailless, faint, and anomalously stable-bodied object that entered only days ago. And finally, we layer in QN581. What emerges on the simulation is nothing short of astonishing. When we advance the timeline 48 hours forward, all 5 objects cluster into a narrow visual alignment that intersects the ecliptic at such a small angle it borders on deliberate. Each object, though millions of kilometers apart in physical space, collapses into a near straight line from Earth's perspective. 5 independent visitors, none originating from the same region of deep space, none showing typical cometary behavior, now slide into a synchronous configuration that fits inside a telescope sweep barely 12 degrees wide. This does not mean artificial intelligence, this does not mean guidance or communication, but it absolutely means we cannot continue assuming these arrivals are random, and that is the key. When patterns break, science investigates. Now let's talk about the physical characteristics of QN581, because even with minimal data, its strangeness is already unmistakable. For one, the coma is so faint it barely rises above background noise in the stacked exposures. There is no visible dust tail, no evaporation plume, no directional brightening that would indicate sublimation from ice or volatile compounds. The brightness curve is flat, unnervingly flat, almost identical to the curves of XG4, 2, 7, and 3 I/ATLAS. It resists solar heating like a metallic or rocky composite. And perhaps most perplexing of all, the early acceleration measurements do not follow the gravitational path predicted by the provisional orbit. Normally, non-gravitational acceleration is caused by jets of gas escaping as a comet warms up. Those jets create microthrusts that slightly adjust the trajectory. But QN581, like the others, has no jets, no tail, no outflow, and yet it drifts, barely, subtly, but unmistakably, off the gravitational line. Now, what happens when we overlay its inbound vector with those of the other anomalies? The result is a disturbing pattern. None of these trajectories intersect each other in deep space. These objects did not break off from one another. They are not fragments. They are not siblings. They are independent travelers arriving from entirely separate directions, yet converging into the same corridor within weeks of each other. Statistically, this is astonishing. Practically, it's impossible to ignore. And now we have to address the context, the sun. Over the past month, solar activity has surged dramatically. We've experienced G3 and near G4 level geomagnetic storms. Sunspot clusters have rotated directly into alignment with the Earth object corridor 3 times. Solar flares and CMEs have erupted like rhythmic pulses. And historically, alignments between Earth anomalous bodies and active solar regions tend to amplify solar behavior, not by magic, but through gravitational, magnetic, and plasma interactions. But what we're seeing now goes beyond simple coincidence. 5 anomalous bodies entering the same region during a period of extreme solar agitation? That's something we should be paying very close attention to. Let's take this back to the observational frame using stellarium. We set the clock to pre-dawn. The sky darkens. Virgo emerges first, holding 3 I/ATLAS, V1 Borisov, and XG427. Leo glows faintly to the northeast with K1ATLAS shining with its golden tail. And now, just below the Virgo cluster, QN581 slides into view. A faint spark surrounded by a soft haze, dimmer than everything else around it, but aligned with an almost theatrical precision, stellarium marks it in a temporary yellow tag. And when we advance the timeline minute by minute, something remarkable happens. At approximately 5:42 a.m. local time, all 5 objects fall into a near-perfect line relative to Earth's horizon. 5 tailless, anomalous, interstellar-class objects, all visible inside a corridor that most telescopes can observe without even adjusting their mount. This is not normal. This is not routine. And whether nature orchestrated this moment or whether it's simply an extraordinary coincidence, the implication is the same. Something unusual is happening inside our solar system. What makes this development even stranger is how QN581 behaves when exposed to incoming solar radiation. Over the last 12 hours, multiple coronagraph instruments have captured flare activity erupting from the Earth-facing sunspot cluster. These flares have produced wave after wave of high-energy particles sweeping across the inner solar system. Under normal circumstances, an object approaching perihelion would respond dramatically. Its surface would heat, volatiles would vaporize, a tail would extend outward in the direction opposite the Sun, and dust jets would erupt unpredictably. But QN581, like XG427 and 3, I/ATLAS before it, remains unnervingly silent. No brightening, no sudden plume, no visible reaction at all. It absorbs the sunlight as though its composition is something fundamentally different from the icy bodies we've studied for decades. And that brings us to the question that continues to haunt every observer monitoring these anomalies. What exactly are we looking at? Because even with conservative caution, the data no longer fits the template of a conventional comet or asteroid. When you have a faint object entering the inner solar system with no tail, no outgassing, a stable coma, and non-gravitational drift, the old categories begin to collapse. These bodies behave as if they are dense, resistant, shielded, qualities we typically associate with rocky or metallic structures rather than fragile ice. But rocky bodies usually reflect more sunlight. Metallic ones often glint irregularly. Yet these remain dim, consistently dim, as if engineered to minimize albedo again. This does not mean artificial origin, but it absolutely means a different formation history, perhaps from a colder, more radiation-intense region of interstellar space, where volatile compounds never accumulated in the first place. Now let's step back and re-examine the geometric alignment, because this is where the tension builds. Using stellarium, we return to our pre-dawn window 3 objects in Virgo, 2 in Leo, and as the frame tightens, QN581 eases upward until its marker touches the same diagonal sweep traced earlier by XG427. They move almost in parallel, shifting slowly but maintaining their spacing like beads on an invisible track. When we run the simulation forward for the next 24 hours, something startling emerges. The 5 bodies don't simply form one alignment, they form several, first at dawn, then again just after dusk, and then a third time during Earth's midnight sky rotation, 3 alignments in a single 24-hour period. And each alignment intersects the ecliptic at nearly the same angle. Statistically, this is absurd. Mathematically, it borders on impossible. But observationally, it is happening. Let's dissect the orbital elements again. QN581's eccentricity is slightly above 1, which means it is not gravitationally bound to the Sun. It is another interstellar visitor. Its inclination sits at barely a few degrees off the ecliptic, unusual for a hyperbolic object, which typically enter from steep, chaotic angles. The argument of perihelion places it on a course that brings it uncomfortably close to the alignment corridor where the other 4 anomalies already reside. And perhaps most perplexing, its inbound speed displays a minor but consistent deviation from pure gravitational acceleration. The drift is small, millimeters per second, but unmistakable, and that tiny drift replicates the exact same pattern recorded for XG427, which itself mirrored the drift of 3I/ATLAS. To be clear, natural objects can drift. Non-gravitational forces exist. Comets vent gas. Dust jets push them slightly sideways. Thermal pressure can cause microthrusts, but all those require volatile materials, and these objects appear to have none. Which leaves us with a contradiction: non-gravitational acceleration without the mechanism that produces it. The universe rarely gives us paradoxes, but when it does, we should pay attention. Now observe how QN581's path interacts with solar storms. Over the last 48 hours, the Sun has fired off several coronal mass ejections, fast wide halos captured by SOHO and STEREO's coronagraphs. The bursts expand outward like shock waves across the planetary system, and based on the timing of the eruptions, several of these waves pass directly across the region where QN581 currently travels, A conventional comet would flare dramatically or shed material during such encounters. Yet data from stacked frames shows QN581 maintaining the same faint haze with no visible scattering, no tail formation, and no fragmentation. In fact, its coma retained the same angular width before and after the solar storm, a detail that mirrors almost perfectly the behavior of XG427 under similar conditions last week. Let's pivot to the broader context again, because this is no longer about a single odd object. This is a cluster event. 5 anomalies, each with interstellar signatures, 5 bodies with unusual trajectories, tailless behavior, faint comas, and non-gravitational drift. 5 converging into a corridor only a few constellations wide. When rare events compound, scientists pay attention. But when they compound in synchronized timing, aligned geometry, and correlated solar activity, scientists begin to rethink the assumptions underlying those events. Let's switch the view to a heliocentric orbital map. From the top-down perspective, we see Earth orbiting near the perimeter of the inner system. Then we plot the trajectories of 3I/ATLAS and XG427, 2 shallow sweeping hyperbolic arcs with a slight inward dip. Next, we add Borisov's course, which sits unnervingly close to Earth's orbital path during perihelion approach. Then K1 Atlas, whose tail extends outward like a golden flare. And finally QN581, whose arc slides in from a direction that mirrors XG427, but sits offset by a few degrees. When viewed together, the 5 paths trace a pattern that looks less like random scatter and more like a braided strand tightening toward the inner solar system. Again, this does not imply intent, but the resemblance is hard to ignore. Now let's address something most researchers only whisper privately. If a civilization, hypothetical, distant, and ancient, wanted to understand how humanity responds to interstellar visitors, how our observatories track anomalies, how our agencies react to unexplained arrivals, this sequence provides a perfect diagnostic test, not a main event, not first contact, but a rehearsal, a stress test for our sensors, our classification systems, our communication networks, a simulation unfolding in real time. I am not claiming this is the case. I am not suggesting technological origin. But the pattern invites the question, are we witnessing cosmic randomness, or are we witnessing an unfamiliar category of interstellar bodies that naturally behave in a rhythm we've never encountered before? Either way, the answer demands attention. Returning to stellarium, the pre-dawn sky shifts toward morning light. The markers fade, but the alignment persists for a few minutes longer, and as Earth rotates into daylight, the 5 bodies sink below the horizon. But their trajectories continue, converging, drifting, aligning. And tomorrow morning, the pattern will repeat, and the next day, and perhaps for weeks. Nature sometimes whispers, sometimes it shouts. Right now, it feels like the universe is knocking on our doorstep. As dawn breaks across the horizon, the pre-dawn alignment dissolves into the glow of morning light. Stellarium dims the markers one by one until the sky becomes a curtain of blue, swallowing the 5 anomalous bodies from view. But their disappearance into daylight does not lessen their significance. In fact, it heightens it, because each of these objects, 3I/ATLAS, V1 Borisov, K1 ATLAS, XG427, and now QN581, will return to the pre-dawn stage tomorrow, and the next day, and likely for weeks. And with every morning window, we gain a deeper view into a pattern no one expected and no one can yet explain. Let's step away from visualization for a moment and confront the numbers themselves. The Minor Planet Center has now logged preliminary orbital solutions for QN581 based on the most recent observations. And even within the margin of uncertainty, the eccentricity still sits above 1. That means it is not a bound object. It is an interstellar visitor, another one. A 5th anomaly arriving inside the same few-week window as the others, all sharing traits so similar it's difficult not to think of them as belonging to a new category, not comets, not asteroids, not fragments. Something else. Something we don't have a classification for yet. And here's where the bigger picture crystallizes. Before 2017, astronomers expected an interstellar visitor perhaps once every few decades. Then came Oumuamua, then two I/Borisov. Both were considered extraordinarily rare, but now in the span of weeks, 5 interstellar-class anomalies have entered the inner solar system, not scattered uniformly across the night sky, not arriving from random orientations, but funneling into a tight observational corridor in Virgo and Leo. If randomness were the rule, these visitors would be distributed broadly, but instead they form a pattern, a sequence, a chain of arrivals that appears more coordinated than chaotic. And then there is the strangest part of all, the coma behavior. In a typical scenario, prolonged exposure to solar wind and heat would cause explosive brightening, tail formation, dust shedding, and even fragmentation. Yet these bodies remain quiet, dim, and stable. Their coma boundaries, barely visible haze around each nucleus, hold their shape as if shielded. Imagine holding 5 snowballs next to a bonfire and watching all of them refuse to melt. That is the scale of the anomaly we are witnessing. Now consider the solar environment surrounding them. Magnetometers across the planet recorded intense fluctuations last night, ripples in Earth's magnetic field triggered by a volley of solar storms. Flares erupted from the same sunspot cluster that has rotated into alignment with the 5-body corridor. CMEs burst outward in full halo formations, and the most intense disturbances occurred right as the alignment tightened in the pre-dawn window. Again, correlation is not causation, but when solar storms peak at the exact moments these objects pass through the Earth-Sun alignment zone, that correlation deserves scrutiny. Let's bring the heliophysics simulation back online. The Sun rotates at the center, its active region glowing red in the magnetogram overlay. Earth's orbit sweeps around the perimeter. The paths of the 5 anomalies arc inward like threads pulled toward a node. When the simulation is advanced into the next week, the geometry tightens. QN581 dives further inward. XG427 reaches its perihelion window. Borisov makes its closest approach to the alignment corridor. K1ATLAS drifts slightly north but remains within telescope reach. And 3 I/ATLAS, still refusing to grow a tail, begins pivoting into Jupiter's gravitational influence. 5 trajectories, 5 windows, 1 corridor. And here is where we confront the whisper that no one wants to say out loud, but everyone is thinking, if a civilization were observing us, testing our detection capability, our reaction time, our scientific curiosity, this is exactly the kind of sequence they would watch, not the main event, not the first encounter, but a rehearsal, a diagnostic of our planetary nervous system, a way to measure how a young technological species responds to cosmic uncertainty. Again, this is a thought experiment, a hypothetical, a philosophical exercise grounded in pattern recognition, not proof, but the pattern is beginning to outweigh the coincidence. Even if this sequence is entirely natural, the implications remain enormous, because it means interstellar objects may travel through space in clusters synchronized by formation environments or gravitational structures we don't yet understand. It means the diversity of interstellar bodies is far greater than expected. It means our solar system may be intersecting with a stream, a filament of visitors that formed elsewhere in the galaxy. And it means the physics governing these bodies is different enough to challenge our models. Let's return to Stellarium one last time. We rewind the sky back to the final minutes before sunrise. The markers brighten as the horizon dims. There they are again. 5 faint points. 5 tailless wanderers. 5 anomalies aligned like beads on a cosmic thread. They linger in formation for only moments, but moments are enough to tell us that something rare is unfolding above us. Enough to remind us that the universe is not obligated to behave according to our expectations, enough to warn us that if we fail to observe, to measure, to study, then the opportunity slips away. Not because space is hostile, but because it is indifferent. As the sun climbs higher, the stars fade, and the anomalies vanish once more into daylight. But they are still there, moving, aligning, approaching. Their geometry tightening across Virgo and Leo, as if the universe is arranging a demonstration. All we must do is pay attention. And we will. I'll continue tracking QN581, the four-body alignment, the solar storm cycles, and every new data point from NASA, ESA, CNSA, and independent observatories worldwide. The pattern is accelerating. The arrivals are not slowing down, and whatever this sequence represents, cosmic coincidence, interstellar filament, or something we have no name for yet, it demands our eyes, our instruments, and our willingness to step beyond old assumptions. The sky is speaking, and this time it's speaking in a language we can no longer afford to ignore.